Hello students, this lesson is on ellipses and how to graph them and write the equations. So in our first example, we're going to state the center, we're going to graph it, and we're going to state the line of symmetry on the major axis. Now the major axis in an ellipse is considered the longer, it's on the longer part of the ellipse. Okay, so starting with this first example, we have this in an ellipse, and there's a couple of things that you're going to need to graph it. The first thing is your center. The center are the numbers that are with the x variable and the y variable, and there's nothing there. So our center is at 0, 0. So we're going to start off by graphing that. The second thing that you need to graph your ellipse is the distance from the center out to the edge, up and down and left and right. And that comes from the denominators. So remember that y squared has a denominator of 1, so we're going to put that over 1. Okay, and if you remember from your standard form, we need to take the square root of those denominators. So if you take the square root of 4, that's going to give you 2. That is that's the distance that you need to go out from the center in the x direction, which would be left and right. So I'm going to go to the right 2, and I'm going to put a point. I'm going to go to the left 2 and put a point, and this is all from your center. Okay? Then you're going to take the square root of 1. Well, the square root of 1 is 1. And that's going to go in the y direction, which is up and down from the center. So you're going to go up 1, and you're going to go down 1. And then now you have the points you need to go ahead and draw your ellipse. So you're going to try and connect those dots, making kind of a football shape. And there is your ellipse. Okay? The other thing that they want you to state is the line of symmetry. Now remember, the line of symmetry of the major axis is the longest part of the ellipse, and it's the part that would cut it in half long ways. So if I'm going to write the equation, this would be my line of symmetry of the major axis, which is the equation y equals 0. Remember, if it goes horizontal, then it's going to be y equals, and if it goes vertical, then it's going to be x equals. And so now we've given all the information that we need, we've graphed it, we've written this down, so we can move on to the next example. Okay, in example 2, notice that we have the y value coming first, but if you remember, addition is commutative, so it doesn't really matter whether the x value comes first or the y value, but in order to keep it from making a mistake like I did on that last video, I'm going to rewrite it with the x value coming first and then the y value. So either one of these is correct. Of course, you don't have to rewrite it, but it just kind of keeps you from making a careless mistake. Alright, so let's write down what our center is. The center, remember, you take the opposite of the numbers with the x and the y, so it's going to be -3 and +1. So let's go ahead and graph that, which would be right here. And this is our center. Okay, then we want to take the square root of the denominator, which would be 2. So going in the x direction, we are going to go 2 places. So that would just be to the left and the right. And then take the square root of 9, and that value is 3. So that's going to go up and down. You're going to go 3, distance of 3 from the center, up and down. And then you can go ahead and you can draw your ellipse. And then they just want you to write what the line of symmetry is, which is along the major axis. So it's going to be a vertical line that cuts it this way. Vertical line is x equals If you just remember what axis it goes through the x-axis, so you're going to start with x equals, and it goes through at -3, so the equation for the line of symmetry is x equals -3, I'm sorry. And then there is your information and your graph. Alright, so for the next example, they're giving us information and then they want us to write the equation. And so to do this, what I always like to do is I always like to graph the information that I'm given. So I'm given that the center is at 2, 3, so I'm going to go ahead and graph that. There's my center. And it says I have a vertex, that's what the V stands for, a vertex at -4, 3, which would be right here, oh sorry, up one more, right here. And then I have another one at 2, 4, which would be right here. Okay, so what I want you to notice is that here's my center, and I have a vertex here and a vertex here. So what I want you to do is I want you to count the distance from both of the vertices. So from here to here, there's a distance of 1. From here to here, I have a distance of 1, 2, 3, 4, 5, 6. And those are the numbers that we're going to use for our denominator. Okay? Well, the first thing that we have to do is we're going to write our standard form equation, which is going to be x, and then you want to take your center and always put it in the equation opposite. So we're going to do a -2 squared, so I'm going to start filling out this information, plus, because ellipses always have a plus, so y -3 squared. I'm going to set up for my denominator, and it's always going to equal 1. So that part of the information, all you have to do is just get it from the center. Okay, now we need to fill in our denominators. Well, in the x direction, the distance was 6. But remember, you're going to square that, and so that would be 36. Okay, so that's 6 squared is going to go into the equation. And then the other part, the y part, is 1, so you're going to do 1 squared, which would just be 1 again. Okay, you can either leave the answer like that, or if you just don't want to put the denominator of 1 there, then you can take it off. Instead of having to rewrite it again, I'm just going to box this as for my answer. Okay? Alright, well hopefully that makes sense. Let's look at one more example. Alright, so this time they give us the center, which is at 6, 8. 8 is going to go off of my graph, but it would be right here. Okay? And they give you a vertex at 6, 5. Which would be right here. So I can already tell that the vertical distance is 3. And then it says that my major axis length is 10. So what I want you to keep in mind that half of that distance would be 5. So from the center out to the vertex, it's only going to go out 5. So 1, 2, 3, 4, 5 would be approximately right here. But really, you know, the key part is we need that 5 there. So if it tells you that the major axis length is 10, it's talking about the whole major axis. So this part would be 5 and this part would be 5, if that makes sense. So the parts that we need for our equation, we need the 5, we need the 3, and then of course we need the center. So let's go ahead and set up our equation. We're going to have x opposite of the center, so -6 quantity squared. I'm just going to fill in the center right now, plus y -8 quantity squared, and it's equal to 1. And then we just have to fill in our denominators. The x denominator goes 5. So 5 squared, remember you have to square it, so it would be 25. And then the y direction the distance was 3, and we square it, and that gives us 9. And there's your equation. Alright guys, short and sweet lesson. Hopefully you understand, but please ask questions on the whisk, and I'll see you in class tomorrow.